Good day everyone, I'm Nestor Pidigusan from BSM2A and I'm here to discuss some lessons and give some knowledge about basic electrical engineering. And the first lesson we will tackle is about atom. So let's watch this video to get some knowledge and ideas and details about atom.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at atoms. All matter is made of elements, substances that cannot be broken down by chemical activity. An atom is the smallest particle of an element that retains the element's properties. Atoms are the building blocks for everything in the universe, including ourselves. People often think of atoms as the smallest possible forms of matter, but even smaller particles make up atoms. Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other, so atoms usually have equal numbers of the two particles. Scientists assign atoms an atomic number and atomic mass unit. The atomic number is the number of protons present in the atom. For instance, a helium atom has 2 protons, so helium's atomic number is 2. Add the number of protons and neutrons in an atom's nucleus together, and you get the atomic mass unit, or AMU. A helium atom has 2 protons and 2 neutrons, so has a mass of 4 AMU. Electrons have almost no mass and are not included in AMU calculations. While an atom's number of protons remains constant, individual atoms can lose or gain electrons. Atoms with different ratios of electrons.
So as we watch the video, atom is the building blocks of everything in this universe, including ourselves. Atom consists of 3 basic particles: protons, electrons, and neutrons. The center of the atom is called nucleus. It contains the proton, who is positively charged, and the neutrons with no charge. The outermost region of the atom is called electron, shell that contains electrons, who is negatively charged. Just how small is an atom? Atom is like a blueberry inside the earth, and the nucleus is like a marble inside a football stadium. Now that we are done in atoms, let's proceed in electricity. Electricity is the flow of electrical power or charge. It is a secondary energy source, which means that we get it from the conversion of other sources of energy, like coal, natural gas, oil, nuclear power, and other natural sources, which are called primary sources. There are 2 types of electricity: the static electricity and current electricity. Static electricity is made by rubbing together 2 or more objects and making friction, while current electricity is the flow of electric charge across an electrical field. To have some knowledge and details about electricity, let's watch this video.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at electricity. Electricity is a natural force that we've harnessed for our energy needs. To understand electricity, we need to know a little more about atoms, the tiny particles that make up our universe. 3 smaller particles make up atoms: neutrons, electrons, and protons. Electrons have a negative charge, protons have a positive charge, and neutrons are neutral. The center of the atom includes neutrons and protons, while the electrons orbit the center like the Earth orbits the Sun. Stable atoms have an equal number of protons and electrons and have no charge. If a material holds on to its electrons tightly, it is known as an insulator. If its electrons are more loosely bound, it's called a conductor. When a large number of free electrons pile up at one end of a conductor, particles that have the same charge repel each other, while particles that have opposite charges attract. These negative electrons push each other apart, jumping from atom to atom through the conductor, creating electricity. There are 2 forms of electricity: current and static. Current electricity travels. It is composed of flowing electrons passing from one atom to another through a conductive material. It is this form of electricity that powers our homes. Static electricity is a charge at rest on an object. Sometimes your body picks up extra electrons through friction and becomes negatively charged. When you touch a conductor, like a metal doorknob, you experience a small shock as the static charge jumps from your body to the doorknob. Electricity is a secondary energy source, meaning we have to convert energy from another source into electric power. Sources of electricity include burning natural gas and coal, nuclear power, and natural sources of power such as wind, water, and solar energy. And that's the shocking truth about electricity. Are called ions. Atoms of the same element can also have extra neutrons. Scientists call atoms with extra neutrons isotopes. Despite having different neutron counts, isotopes retain their element's chemical properties because the number of protons remains constant.
Now that we are done discussing atom and electricity, let's proceed to electric charge and electric current. And now let's proceed to the discussion of electric charge and electric current. 1 electron equals 1.6 times 10 raised to negative 19 coulomb, and 1 coulomb equals 6.24 times 10 raised to 18 electron. Note, when 1 coulomb of electric charge continuously passes a given point per second, the electric current is said to be 1 ampere. Lagi nating tatandaan na yung 1 coulomb of electric charge ay patuloy na dumadaloy sa isang given point per second. Yung electric current niya is 1 ampere. Therefore, yung 1 ampere equals 1 coulomb per second. And 1 ampere equals also sa 6.24 times 10 raised to 18 electron per second. Roughly, 1 ampere contains 6 billion electron passing to a certain point per seconds. So, iisipin na pala natin na ganun pala kadami yung electron sa isang ampere. Paano pa kaya pag yung ampere nasa 5 or 10 na, sobrang dami na pala, ano? Kung yung isa nga 6 billion, ano pa kaya yun? Parang maiisip pala na natin na yung 1 ampere, yung electron nun, pag binilang natin, parang infinity na din yung dami ng electron. Kasi hindi na siya countable ng kamay natin or what. Medyo mahirapan na tayo doon. Kaya dahil dyan, puproceed na tayo sa formula niya. Electric charge and electric current leading to the formula of I equals Q over T, where I equals current, which is symbols A, big letter A, and Q charge. Q equals charge, na yung symbol is big letter C. And T equals time, na yung symbol naman is small letter S. And proceed naman po tayo sa electron drift velocity. Ito yung dimensional analysis ng electron drift velocity. Tingnan natin, ayan, makikita natin siya dito sa screen. And next po natin is yung itong table 1, electron density. Yung conduction electron densities and Fermi energies for some metals. Ito yung mga element, tapos ito yung mga elements niya. Ito, makikita natin yan, yung elements niya. Tapos yung conduction band and electron naman, ito. Yan, tingnan natin dyan, ito. Tapos yung pre-electron model, Fermi energy, small letter E, EV. Ayan, ito yan. Look, ayan o. Tapos dito naman sa table 2 natin, ito yung medyo maganda rin. Tingnan natin kung ilang ampere yung kailangan para makapatay ng isang tao. Ayan, tingnan natin dito sa may table. Sa table ng electric hazard. 1.0 ampere, nagkakasya ng severe burns, breathing stops. Tapos yung 0.2 to 0.1, nagbibring sa tao ng death. And then yung death, nagbibring siya ng death, extreme breathing difficulties, breathing upset labored, severe shock, muscular paralysis, cannot let go, painful shock. And 0.01 naman, 0.01 ampere, mild sensation, and 0.001 threshold of sensation. Ibig sabihin pala yung 0.001, ganun nakalakas siya na pwede magdulot ng injury sa atin. Tapos yung 0.01 mild sensation, and yung 0.1 pala, yung 0.1 na ampere lang yung madikitan ng katawan natin, o yung isang daliri lang natin, o kahit isang hibla, basta magdadalo yung kuryente, mamamatay na pala tayo sa 0.1 ampere na yun. And paano pa kaya yung 1.0 na merong 6 billion electrons, ano? So, next na po tayo. Dito na tayo sa electric wire standards. American wire gauge or yung AWG, also known as the Brown and Sharp wire gauge, is a logarithmic step standardized wire gauge system used since 1857, predominantly in North America for the diameters of round, solid, non-ferrous electricity conducting wire. Yung American wire gauge pala yung logarithmic na nag-standardize ng mga gauge since 1857 na nagmula sa North America. Tapos, dimensions of the wires are given in ASTM standard B258. The cross-sectional area of each gauge is an important factor determining its current carrying capacity. So, yung AWG pala is napaka-importante kasi siya yung nagde-detect ng cross-sectional area, tapos kung ano yung kayang dali ng mga wire. Yung wire capacity. Also, the AWG tables are for a single, solid, and round conductor. Yung table ng AWG, doon natin makikita yung single, solid, and round conductor, kung ano yung mga capacity nila. The AWG of a stranded wire is determined by the cross-sectional area of the equivalent solid conductor. Because there are also a small gap between the strands, a stranded wire will also have a slightly larger overall diameter than a solid wire with the same AWG. So, dun pala natin makikita na even yung smallest wire na malagot lang doon, napakalaking bagay pala yung nagagawa nun sa daloy ng electricity sa mga electric wires natin. Kaya salamat sa American wire gauge, it's easy for us to determine kung ano ba yung kailangan natin gamitin. Tapos sa AWG, may rules of thumb tayo. Yung rules of thumb natin, basahin na lang natin. Mas maiintindihan kasi natin to pag nakita na natin mismo yung table Kaya, pero basahin pa rin natin muna. When the cross-sectional area of a wire is doubled, the AWG will decrease by 3. Example, yung number 14, AWG wires have about the same cross-sectional area as single number 11 AWG wire. Nadodouble niya yung conductance. When the diameter of a wire is doubled, the AWG will decrease. Pag yung haba naman is na doble, yung AWG niya, yung American wire gauge niya, mas bababa naman. Example, yung number 2 na AWG is about twice the diameter of number 8. This quadruples the cross-sectional area in the conductance. A decrease of 10 gauge number, for example, from number 12, bababa siya ng number 2, multiplies the area and weight by approximately 10, and reduce the electric resistance and increase the conductance. Ibig sabihin pala na mentras bumababa yung number, tumataas yung conductance nung wire. Ayan, nabasa na natin yung rules of thumb. Now, let's proceed to table naman ng American wire gauge. Yan, ito yung American wire gauge. Sample na natin dyan yung gauge na 4 na 0. Yung conductor diameter niya, yung inches niya is 0.46 lang. Yung conductor diameter niya in millimeter naman, 11.684. Tapos yung conductor cross section area in millimeter squared, ayan naman 107. Yung ohms per 1,000 per feet, dito natin talaga makikita, napakaganda talagang na na-discover ito kasi dito na natin makikita yung kailangan nating wire, kung anong wire yung gusto natin para daluyan ng kuryente para sa mga bahay natin. Minsan nagdi-discuss yung teacher namin na tanong niya, anong wire ba yung magandang daluyan ng kuryente? Syempre mapapaisip ka, syempre hindi naman pare-parehas yung wire, may mataba, may mapayat, may mahaba, may maikli. Pero tumagal yung discussion namin nun about din dito sa may dinidiscuss ko ngayon. Ayan, malalaman din natin yan. Pag tinignan natin itong malalaman natin na yung maganda palang daluyan o conductor na wire is yung matabang maikli. Kasi, syempre, tinitingnan ko rin na principle nun Saan nga ba, ano ba ang mas mabilis? Kunwari na lang, kung may pupuntahan tayo, saan ka mas mabilis makakarating, yung mahabay dadaanan mo o yung maikli? Kaya ganun din siguro sa wire. Na pag yung wire dumaloy sa maikli, mas mabilis yung conduction niya. mas maganda namang conduction yung yun nga, yung sasabi ko lang na maikli na mataba. Ayan. So, ayos na tayo dun sa American wire gauge. Siguro naman, sa pag tinignan natin, ayan, balikan natin mula dito sa may one American wire gauge. Yan, makikita natin yung mga units niya, yung mga kailangan. Napakabisa, napakaganda talaga. IEC 60228. IEC 60228 is the International Electrotechnical Commission's International Standard on Conductors of Insulated Cable. Yung IEC 60228 ay yung commission ng mga standard conductors of insulated cables. As of 2020, the current version is 3rd edition 2004-11. Among other things, it defines a set of standard wire cross-sectional area. Yung IEC 60228, siya pala yung nagde-defines ng set of standard wires into cross-sectional areas. O ang titingnan natin para makita natin yung cross-sectional areas ng mga standard wire, maaari tayong tumingin sa IEC or International Electrotechnical Commission's Standards on Conductors of Insulated Cables. IEC 60228, it specifies the nominal cross-sectional areas in the range 0.5 mm squared to 2,500 mm squared for conductors in electric power cables and cord of a wide range of types. Requirements for number and sizes of wires and resistance value are also included. So dito pala sa IEC 60228, yung electric power cables, cord, wide range, kabilang na dito. Lahat ng klase, pwede nating makita dito sa International Electrotechnical Commission's International Standard of Conductors of Insulated Cables. These conductors include solid and stranded copper, aluminum, and aluminum alloy conductors in cable for fixed installations, and flexible copper conductors. Yung mga conductors na nakabilang dito is yung solid, stranded copper, aluminum, and aluminum alloy conductors na pang cable, and also yung fixed installations of flexible copper and conductors. And after that, let's proceed to table of IEC 60228 o yung mga or yung international standard wire sizes IEC 60228. Ayan, 0.5 mm squared, 0.75 mm squared, 1 mm squared. So ayan ang makikita po natin dyan sa table. Ayan, pagtingin natin yan, nakikita po ba? Dito makikita natin yan. Nandyan yung mga sizes. So ang sizes pala na ginamit dito sa IEC is millimeter squared. So yan, tingnan muna natin. Diyan natin makikita yung mga cross-sectional areas ng mga wire at yung sizes niya. Standard po lahat yan. Yan. Diyan yan sa IEC 60228. Okay na tayo dyan, and next na po tayo. Next na po tayo dito sa solid wire versus stranded wire. Stranded wire pros. The bundled braids of stranded cable offer a few acute benefits over solid wire. Flexible, malleable, will not split or sever. Yung stranded wire pala is mas flexible kumpara sa solid wire. Mas malleable din siya and mas matibay siya kasi nga flexible siya. Kahit ibaluktot natin, iikot natin, hindi kabod siya mag-i-split o hindi maghihiwa-hiwala yung mga wire niya. Stranded wire applications. Stranded wires are more suited to indoor applications where bending and twisting are necessary to connect electronic components like circuit boards, speaker wire, electromechanical assemblies. Yung stranded wire pala is mas magandang gamitin o mas fit siya sa indoor application. Gaya ng anong sinabi dito sa circuit boards and speaker wires and electromechanical assemblies. Yung mga binabaluktot ba natin katulad na lang sa wires, sa speaker wires, di ba pag sinasaksak natin yung mga wires sa speaker, kailangan muna nating bilutin para pumasok siya dun sa misaksakan. Kaya mas magandang palang gamitin doon yung stranded wire. So, punta na tayo dyan. Next na tayo. Resistance and resistivity. Resistance is the measurement of material's capability to oppose the flow of current. The unit of resistance is ohm. Lagi nating tatandaan yan, huwag nating kalimutan na ang unit ng resistance is ohm. Thus, from this definition, the higher the resistance, the lower capability to conduct current and vice versa. Ayun, sinasabi rito na the higher the resistance, the lower capability to conduct current. Na ibig sabihin na mentras tumataas yung resistance, bumababa yung kapasidad niya para mag-conduct ng current. Kabaligtaran naman nun, mentras tumataas yung current, bumababa yung resistance. And then, the resistance of an object is dependent to kinds of materials, cross-sectional area, length, temperature. Nababase yung resistance, depende sa gagamitin nating material, yung sukat niya, yung cross-sectional area niya, yung haba, at yung temperatura. And then, next tayo. Resistivity naman, resistivity or specific resistance is also the measurement of material's capability to oppose the flow of current. The SI unit of resistivity is ohmmeter, and for the English system is centimeter ohm per feet. Unlike resistance, resistivity is an intrinsic property. Its value is constant regardless of length and cross-sections. Its measurement is affected by the following kinds of material and temperature. Hindi gaya ng resistance, yung resistivity, ang nakakaapekto lamang sa kanya ay yung kinds of materials at temperature. Kanina masasabi dito sa resistance na merong nakakaapekto sa kanya na cross-sectional area, yung length. Dito naman ang nakaka-apekto lang ay yung kinds of materials and temperature. Also, sinasabi dito na intrinsic property siya. Yung value niya is constant regardless of length and cross-section. Yun nga. Hindi inaano dito yung haba niya o yung cross-section niya. Yun ang pinakaiba ng resistivity sa resistance. O ano tayo ulit, summary tayo dito sa resistivity and resistance bago tayo lumipat ng panibagong slide. Yung resistance, ang nakaka-apekto sa kanya, kind of materials, length, cross-sectional area, and temperature. Dito naman sa resistivity, yung kinds of material lang at temperature. At ano na nga ulit yung unit ng resistance? Ang unit ng resistance ay ohms. Ang resistivity naman ay ohmmeter, and for English system is centimeter ohm per feet. Lagi nating tatandaan yun na, huwag nating kakalimutan kasi mas magagamit pa natin to sa mga susunod pa nating topic, sa mga darating pang topic dito sa basic electrical engineering. And next slide na po tayo. Resistance and resistivity. Yung resistance and resistivity, nag-lead na siya sa formula. Yung R equals yung parang pinamaliit na medyo nakasaside siya, I over A, which yung R equals resistance, yung resistance ay ohms, yung resistivity naman yung parang pinamaliit, ohmmeters, o sa English system ay centimeter times ohms divided by feet, and yung L naman is mali ako. Ang leading formula pala ng resistance and resistivity, R equals like P na maliit, L over A. Yun nga ang ibig sabihin pala ng L length or meter per feet. Yung A naman is cross-sectional area, which is meter squared, inches squared. And next tayo. Resistance and resistivity. Area in circular mills, centimeter, where A equals D squared, where A equals area centimeter, D equals diameter mills. Yung 1 inches equals 1,000 mills. Yung ibig sabihin, yung 1 inch equals 1,000 mills, then yung 2 inches equal 2,000 mills. Something like that lang yun. Basic components lang yan. Kaya pa natin yan. And next na tayo. Resistance and resistivity dimensional analysis. Ito yung SI unit, kung SI unit kagaya rin nung kaninang pinakita natin. Ohms times meters, M over M squared. Yung American customary system naman ito sa may baba, ito na may American customary system, ito yung dimensional analysis niya. Tapos pag nilipat natin sa American customary system, ito centimeter times ohms over feet over centimeter. That's it. Yan. Ito naman yung common element ng resistivity natin. Ayun, ito may tanong pala ako sa inyo. Ano yung pinakamagandang conductor? Sasagutin ko na rin kasi nakikita naman natin sa table na ang pinakamagandang conductor silver. Marami sa atin nagtatanong bakit hindi nung ginagamit natin sa mga kuryente natin sa bahay. Ang unang-unang dahilan dyan mahal. Kaya ang ginagamit na lang natin, ang kadalasan nakikita na lang natin yung copper o yung tanso. Ang ginagamit natin, yung tanso yung kung hindi pa natin alam, yung mga kinukuha natin sa mga nakalagay sa wire, binebenta natin dati. Yon. Pangalawa siya sa pinakamagandang conductor. Makikita naman natin dito. Ayan, 1.59 times 10 raised to negative 8 yung silver. Tapos sa English, SI unit, 9.6. Sa yung copper naman 1.77. Dito talaga makikita natin na mentras na mababa ang resistivity, napakagandang conductor. Ayan, pinakamababang resistivity dyan yung silver. Sinusundan ng copper, annealed copper, gold. Isipin natin, maganda rin pa ng conductor yung gold, ano? Nasa pang-apat pa siya. Next na tayo dyan. Ang mahalaga lang naman dito, makikita natin na ito, patunay lang to na mentras mababa yung resistivity, magandang daluyan ng kuryente. At ang nangunguna dyan, silver, pangalawa yung copper. Ayan, ganun din yan. Isipin natin, ultimo pala yung dito sa dulo. Isa-isayin nga natin to. Mas maganda. Aluminum, tungsten, zinc, nickel, lithium, iron, platinum, tin, lead, titanium, mercury, nichrome glass. Ultimo pala glass. Pwedeng daluyan kaso medyo malabo na yun. Maliit na lang. Na resistivity, napaka taas na niya. Pati yung hard rubber, pati yung wood oven drive, pati nga yung hangin pwede. Dito naman tayo. Okay, yari na tayo dito. Next naman natin, dito na tayo sa temperature effect on resistance. Material that are classed as conductor tends to increase the resistance with an increase in temperature. Materials that are classed as conductor tends to increase the resistance with an increase to temperature. Yun, mentras pala nag-i-increase yung resistance ng conductor, nag-i-increase din yung temperature, which mean pag tumataas yung temperatura, tumataas yung resistance. Ibig sabihin mas nahihirapan dumalo yung kuryente pag mataas yung temperature, pag mas mainit. Napapansin nyo ba na pag nag-charge din tayo ng cellphone, pag mainit, parang pag mainit yung panahon, matagal mag-charge yung phone, tas umiinit pa. Pero pag malamig naman, smooth lang, tas parang medyo bumibilis. Ewan ko kung ako din nakapansin, pero para sa akin, isa to sa pwedeng maging basic para para mapaliwanag tong sinasabi dito na increase the resistance with an increase in temperature. Dito naman tayo sa insulator. Insulator, however, are different. It tends to decrease the resistance with an increase in temperature. Yung insulator naman pala, nagdi-decrease yung resistance niya pag nag-i-increase yung temperature. Kabaligtaran siya ng conductor. Yung insulator, pag nag-increase yung temperature, bumababa yung resistance, gumaganda yung pasok ng kuryente. Materials used for practical insulator, glass, plastic, etc. only exhibit a mild drop in the resistance at very high temperature. They remain good insulators over all temperature they are likely to encounter in use. Yon. Next tayo. The higher the temperature, the more violently the atoms vibrate. In a conductor which already has a large number of free electrons flowing through it, the vibration of the atoms causes many collisions between the free electrons and the captive electrons. Each collision uses up some energy from the free electron and is the basic cause of resistance. The more the atoms scrambling around in the material, the more collisions are caused and hence the greater the resistance to current flow. In an insulator, however, this is a slightly different situation. There are so few free electrons that hardly any current can flow. Almost all the electrons are tightly bound within their particular atom. Heating an insulating material vibrates the atoms, and if heated sufficiently, the atoms vibrate violently enough to actually shake some of their captive electrons free, creating free electrons to become carriers of current. Therefore, at high temperature, the resistance of an insulator can fall, and in some insulating materials quit dramatically. Ayun pala yung paliwanag dito sa pagtaas ng temperatura sa pagbaba naman ng resistivity dito sa insulator. Yun nga, kasi insulator siya, mas maganda talagang daluyan ng kuryente. Dito yan, dito sinasabi yun. At high temperatures, that resistance of an insulator can fall, and in some insulating materials quiet dramatically. Yon. Next tayo. Tapos dito naman tayo. Ito na yung temperature effect on resistance. R2 equals R1, 1 plus infinity parang putol, delta T, where R2 final resistance, yung R2 equals final resistance, R1 equals initial resistance, itong parang infinite temperature coefficient of resistance, which value is Celsius raised to negative 1, equals 1 over T plus T1, yung ting malaki, inferred absolute 0 degrees, 0 Celsius, delta T, change in temperature, degree Celsius, equals T2 minus T1, T2 equals final temperature, T1 equals initial temperature. Ito, temperature effect on resistance pa din. The inferred absolute temperature is the temperature at which a system is in the state of lowest possible minimum energy. As molecules approach this temperature, their movement drops towards zero. It is the lowest temperature a gas thermometer can measure. No electronic device work at this temperature. The kinetic energy of the molecules become negligibly or zero. The inferred absolute temperature pala walang electronic device na magwo-work pag yung temperature is inferred absolute. Kasi nga it is negligible or zero. So ito, makita naman natin dito yung inferred absolute temperature table. Ayan, makita natin dyan, material, silver, copper, gold, aluminum, tungsten, nickel, iron, nichrome, constantan. So dito na natatapos yung discussion ko. Sana marami kayo natutunan. At see you soon ulit sa susunod na discussion at video na gagawin ko para sa konting kaalaman sa basic electrical engineering. At gusto ko pa lang magpasalamat kay Sir Marvin Bartolome dahil sa kanya ko nahiram tong PDF na to. Siya yung nag-send na to sa discussion namin. Sinend niya para ipagbasihan kami at ito nga pinag-aralan natin yan. Maraming salamat kay Sir. Thank you. At God bless and have a good day. And gusto ko lang mag-iwan ng isang quotes about electricity. God is our electricity and we are the lamps.